recrystallization is still the most important technique for the purification of organic compounds. For its success, it relies upon the assumption, which is usually true, that compounds are more soluble in hot solvents than in cold. For the process to succeed, the impurities must either be very much less soluble in the solvent than the substance being purified, so that they can be removed by filtration, or alternatively being much more soluble, so that they'll stay in solution at the end of the recrystallization process. In this demonstration, I'm going to show you how to carry out a simple recrystallization, that is, using a single solvent system. In order to do that, you first have to select an appropriate solvent. You do that by carrying out tests on small amounts of the substance in ignition tubes, such as these, using a range of solvents of differing polarities. We've selected a range of solvents here which span much of the polarity range that's usable. Alcohols, such as methanol and ethanol, are very polar hydrogen bonding solvents. Somewhat less polar than these are the dipolar aprotic solvents, such as dimethylformamide and dimethyl sulfoxide. Less polar still, propanone, that's acetone, and trichloromethane, chloroform. And least polar of all, petrol, which is rather unfortunately labeled petroleum ether, but is simply a mixture of low-boiling alkanes. And so I'll show you, using some of these solvents, how to select an appropriate solvent for the recrystallization, using small amounts of this material. So take an ignition tube and put into it just a very small amount of the material, just enough to cover the end of a spatula, and pour onto that a small volume of the test solvent. I'll try with some methanol, just a few milliliters. Shake and note your observations. You can see that the solid has very quickly dissolved. This material dissolves in cold methanol, and so methanol is not a suitable solvent for the recrystallization. Take a second ignition tube, repeat the process as before, just enough solid to coat the bottom of the spatula, and again, put a few milliliters of solvent onto that. I'll try propanone. Again, only a small amount of solvent necessary. And again, shake and observe and note your observation. You will see that once again, the substance has dissolved very rapidly in the cold solvent. So propanone is also an unsuitable solvent for recrystallization of this material. Clearly, this material requires something of much lower polarity than the alcohol that we used or propanone. And so let's try now the most non-polar solvent that we have, that is petrol. Again, a small amount of the solid and a few milliliters of petrol onto there. Shake and observe. And you see that the solid material is not dissolving in the petrol. It's still on the bottom of the ignition tube. So potentially then, petrol is a suitable solvent for this recrystallization. What we must now do is heat this solution up to see if the solid will dissolve in the hot solvent. To do that, we take the ignition tube in some wooden tongs and hold it in the steam bath. The solvent will quickly start to boil. I think you can see bubbles already rising in it. A little bit of patience is required here because the dissolution of the solid takes time. So give it a minute or two to make sure whether the solid is dissolving or not. What we need to do now is to test that we can bring the material back out of solution by cooling it down. So take the tube to a beaker of iced water and plunge the tube into the beaker. Just agitate gently. Just for a few seconds to make sure that the solvent starts to cool, and then bring out. I think you can see that the crystals are now just starting to form in the bulk of the liquid. We'll put it back into the iced water again, a little bit longer. There you can see now very clearly the white crystals forming in the ignition tube. And so we have here clearly the potential for recrystallizing this material from hot petrol. Once a suitable solvent has been selected for the recrystallization, in this case petrol, the next stage is to recrystallize the bulk of the material. And to do this, I'm going to use a round-bottomed flask. We have to get a suitable amount of the material into the flask, and to do this, you could use a number of ways. With a wide-necked flask, you could use a powder funnel like this, or you can make a funnel out of filter paper or weighing paper, or you can just use a spatula, which is what I'm going to do. Take the spatula and a suitable amount of the material. For this demonstration, I think that will probably be enough. Then take the flask over to the steam bath, and since we're using an inflammable solvent, we shall put a Liebig condenser on top of the flask. This is a good precaution, whatever solvent you're using, because then it stops solvent escaping into the environment. We next pour some solvent down into the flask, and I've already prepared some hot petrol here. So cautiously pour a small amount of hot petrol into the flask. Agitate the flask. Caution is required here. You don't want to add too much solvent. A common failing in recrystallization is to use too much solvent. What happens is the stuff then goes into solution, but on cooling will not come out again. So just add small amounts of solvent, as I'm doing now. Agitate the flask gently. Then keep adding until the bulk of the material has dissolved. You don't necessarily have to dissolve all of the material. Some impurities might well be insoluble impurities, and so you won't be able to dissolve them anyway. So don't necessarily hope for every last particle to disappear. Just make sure that the bulk of the material has gone. Now, whilst we're waiting for that material to dissolve, I'll show you how to prepare the filter paper for the next stage, which is the filtration of the hot solution. And we're going to do that through a fluted filter paper. This is a filter paper containing many more folds than you normally use, and what it means is that the liquid can be filtered much more rapidly than normally, and that in turn helps to avoid recrystallization occurring actually in the filter funnel. So what you do is you start with an ordinary filter paper, folding it in the usual way, into quarters. Then fold the quarters into eighths, and again fold the eighths into sixteenths. Those are the two outer ones, there. Now fold the inner two segments there. And then finally, fold back to form a fan arrangement like that, which, when opened up, will give us the fluted filter paper that we need. We shall then place the fluted filter paper into a preheated funnel. The funnel that I'm going to use has a sawn-off end. This also is very useful because it means that there's less danger of the liquid cooling in the stem of the funnel and causing crystallization to occur there. So we'll take this funnel over to an oven and heat it in the oven to get it hot. An alternative method is to hold the funnel by the stem using a cloth and very cautiously pass the funnel through a Bunsen flame. But it's better, if possible, to use a hot oven to heat the funnel. If we return to the steam bath now, see that not all of the material has dissolved by any means, so we can add some more solvent down the Liebig condenser. And leave that for a while until we're confident that the bulk of the material has dissolved. When it has, we shall be ready then to carry out the filtration. As you can see, virtually all the material has dissolved. The solution is now almost clear, and so we're ready to filter it. I have here a preheated filter funnel from the oven, so place that in a ring and then put the fluted filter paper into that. Take the condenser out of the flask, holding the flask firmly in the wooden tongs. Lift up the condenser, clamp there, and take the solution over to the filtration equipment and pour the solution into the filter paper. Notice that the size of the filter paper has been chosen so that when folded, it almost fills the glass of the filter funnel. You should now leave the solution to cool naturally on the bench for the crystals to form. And once the crystals are precipitated, we shall isolate them using vacuum filtration. For the vacuum filtration, we shall use a Buchner flask. This is connected to a source of vacuum, in this case a water pump. We can use a variety of sizes of funnel. For very small amounts of substance, we could use the Hirsch funnel, but for greater amounts, such as we shall have here, a small Buchner funnel is more appropriate. And for this, we need a disc of filter paper, chosen in size, so that the holes are just covered by the filter paper. Vacuum is established by means of the rubber ring. We close the tap here and press down gently on the funnel. Before carrying out the filtration, moisten the filter disc with a small amount of the recrystallizing solvent. This beds the disc down onto the surface of the funnel. Now, take the solution containing the crystals, swirl to get the crystals suspended, and pour the solution onto the funnel, swirling regularly to keep the material in suspension. Rinse out the flask with a small amount of recrystallizing solvent to ensure that all the crystals have been removed from the flask. Then press down the crystals into a cake from which the solvent can be sucked more readily. Release the vacuum by lifting up gently on the rubber ring and pour onto the cake of crystals a small amount of the recrystallizing solvent. Then press down to suck that through. This has the effect of washing the surface of the crystals, removing any impurities from them. You can do this 2 or 3 times if you like, but you should take care not to use too much solvent because that can dissolve away the crystals and reduce the final yield. Unless the material is air sensitive, this can now be left to suck dry for a few minutes on the Buchner flask. When the material has sucked dried, finally release the vacuum by lifting up on the rubber ring, turn off the water pump, and ease the crystals out of the funnel onto a watch glass. Take care not to scrape the surface of the filter paper because this could contaminate the crystals with fibers of the paper. With a volatile solvent such as we have used here, the crystals can be left to dry on the open bench. With less volatile solvents, it's probably necessary to dry the material in a warm oven, taking care to set the temperature of the oven well below the melting point of the crystals. If any residual color is left behind in the crystals, then a useful trick is to add some decolorizing charcoal into the hot recrystallizing mixture before filtration through the fluted filter paper. This has the effect of absorbing small amounts of colored material and of improving the final appearance